build applications, we have to be able to make them secure. So we're going to look at that today. If you want to open up your everything store, just before we do need to address one small issue from last week's lesson that I didn't realize because it's an edge-specific problem, which Anjali was good enough to, and Lynette were good enough to point out. So I'm going to open up my everything store and just get it launched. And the issue that we had, which was kind of interesting, was Anjali came to my office and we looked at her code and she said, my files won't upload. I get an error every time I try and upload a product image. It's giving me saying an invalid path error, and we checked our code and our code was exactly the same. And eventually we realized, one thing I haven't really shown you guys is how to use the runtime debugger with Visual Studio. This is super handy. So Visual Studio and .NET, this was the first time that web developers could run their application at runtime and walk through the code line by line with a breakpoint in the way you're used to doing with desktop apps. So eventually we figured out that the file uploads work in Firefox and Chrome, they don't work in Edge. And we'll look at why and then we'll fix that. So I went in here to my products. So I'm going to do another file upload. I'll do one through Firefox and then I'll try it through Edge and we'll see what happens. And then we'll turn on the debugger, see why Edge behaves differently, and we're going to have to make a little change to our upload code to fix this, because we don't know what browsers our users are using. So I will go and grab maybe another product image. That's not the right book. This is actually a really interesting book. Highly recommend it. So I'll just save this on my desktop. Actually, I'll try and upload it here through Edge first. Now you'll notice, so I'll do it here. I won't actually submit it in Firefox. I'll try and do the same thing. I pick it. What do you notice visually about that file upload control in Firefox? And Chrome would have the same representation as Firefox if you try it in Chrome. What do you notice about it in Edge? So look here. Right, in Edge, it shows the full path. Not only does it show the full path, but when we try and save the file and we retrieve the name, so this is the error some of you may have gotten if you tried this in Edge. It says path isn't supported. So to debug this, we looked at the code, we couldn't quite figure out why. So I'm actually going to put in a breakpoint here. Most of the time when I've been running my applications, I've been using the start without debugging option. This time I want to start with debugging because I want my code to hit that line, and then I want to be able to look at the code and inspect it line by line, and we can figure out what's going on. So I'm actually going to start my debugger. I already know this works in Firefox. We've already tried it last week, and I was able to upload those two files. But when we try the same code in Edge, it doesn't seem to work. So I'm going to use the debugger, and I'll show you what Edge does that Firefox doesn't do. And then we're going to need to refactor the code a little bit to account for Edge's implementation of the file upload. So now my code hits my breakpoint. So here's our issue. Our file.file name when we use Edge it includes the full path. And then our line of code down here on line 97, right? So our path is going to be C, the full path of my project, but then we have the full path inside of it. We don't want any of this. We don't care the original source of the file. We're only interested in the file name. Now the file upload implementation in Chrome and Firefox, it works. It only gives us this value. It ignores the original source of the file, doesn't care. But in Edge, it's including that path, which therefore crashes our upload, where we've got one path inside of another one. So that's not going to work for us to save this. So I'll just let it crash and I get this. So we're going to need to refactor this code a little bit so that if the user is using Edge, we just want the name of the file, the wave.jpg. I don't care where the file came from. So to do this, I've got to stop my debugger. I can't make any changes when it's active. So I'll make a variable called fname. So if we call path.getFileName, that's going to strip out move path from Edge. Now it doesn't recognize this library, but it gives me a little code hint here. If I mouse over, do you want to make a reference to the system.io namespace? If we do that, we can then use that path class. So I'll just accept that little suggestion. Visual Studio adds this reference to system.io up here. So now instead of using file.filename, we want to use our fname variable instead, both here when we save the file, as well as here when we save the name to the database. So this method won't really do anything in Firefox or Chrome. The path has already been removed. We already have the original file name. But this will strip out that original path in Edge. So now I'll have to start the server again, because once you start debugging and press stop, you've shut the server off. So I'll start without debugging, and I'll try this again now using Edge. This error should go away now. I'm just going to try it. I'll put the code back up. I know probably still want to see it. We'll see if it's right, and then I'll put it back up. Okay, so I'll try one more time. And now the upload works. So I've replaced file.filename on line 100 and 102, and then added line 98. So, Angeli, thank you for coming and telling me about this. I'm sorry you spent several hours trying to get this to work. And I don't typically use Edge, so it's good to know, right? And we can see the importance of, again, testing across multiple browsers. That the implementation of certain things, not just on the client, but on the server, may be different in different browser. I think next time I teach this class, I won't show my class that code yet right away. I'll do it the original way first and show them why it crashes in Edge. And then we'll do it this way so people understand the importance of refactoring the code this way. So now it should work in any browser. Just going to open up my database for a minute. Does anybody have any questions about that change that we've made? Okay. Excuse me. So I want to give you a look at kind of what we're going to be doing today. So right now we've got this application where everything's public, right? Our product catalog is public, our categories list is public, and anybody who comes to the site can do anything. They could delete everything from the database, they could put a whole bunch of junk in there. So obviously we're going to want to change this. So when we think about web application security, go here. Go away. Okay. What's the first thing to come to mind when you see that term, web application security? What do you think about? Okay. What else do you think about? Okay. What else comes to mind? Okay. What else do you think of? Anything that comes to mind? You think of security. Are there any sites as a user you won't go to for security reasons? Sorry? Okay, yep. Anything else you think about? Okay, so that'd be. Okay. These are all good. Anything else we've got to think about? We've built an application and now we need to make sure that it's secure. Oh, okay. Now, we don't typically encrypt passwords. What do we typically do instead? What's the difference between hashing? What's the difference between hashing and encrypting? They're similar, but they're not the same. Right. Encryption is two-way. If you can encrypt a value, you can decrypt it. Hashing, it's only one way. It can never be converted back into its original value. So which is going to be more secure? Hashing, obviously, is going to be more secure. Anything else we should think about? What about related to user accounts? User accounts is one level, right? Well, yes, so user accounts is authentication. So that's kind of our first level of security. What's the second level above and beyond that? Authentication is all around identity. Do we know who the user is, or are they anonymous? So that's kind of the first level. That's at its most basic. What's the more advanced level beyond that once we know who users are? Think of Blackboard. Think of all of us in this room and security on Blackboard. So user account is about identity, figuring out who the user is. Authorization is then the next level, and not all sites need authorization. With some of them, so long as you log in, you can do anything there. We don't really care. There's no separate levels. But most applications like Blackboard, first we identify you, right? If you're anonymous, you can't do anything on Blackboard. You have to have an account. And then once you have an account, the next question is, okay, now we know who you are. What are you allowed to do? All right. So these are all things that, or most of these are things we're going to implement and think about in today's class. So we want to make it so that two things. First, we'll make it so that only an authenticated user can manage the data in products and categories. But really, it shouldn't just be any user with an account. It should be a user, right, that has certain permissions. They're an administrator of the site that can modify this data, right? Because if I'm going to shop on the site, I'm going to have an account. Eventually, I'm going to be able to register and log in. Doesn't mean I should be able to change the prices of the products in my shopping cart. Might be nice as a customer. Probably the site owner is not going to be very happy with that. So we're going to need some different levels of authorization around that. So as you can imagine from all of the automated stuff Visual Studio has been doing for us, it also automates a lot of these things. Okay? So there's sort of two frameworks. The general framework we're working with is called ASP.NET Identity. This diagram's a little old, but it still gives you an idea how it works. So ASP.NET Identity, it works with this Microsoft middleware called OWIN. So we can use OWIN in any kind of Microsoft application. It could be an API, it could be a desktop app, it could be a mobile app, it could be web. So this is middleware, it sits below the web application layer. So this ASP.NET Identity, it's kind of a library that works with OWIN, and then it talks to Entity Framework and our database. So there's kind of like how the whole schema looks like. And when we set up our project, remember, and you did this, I asked you to do this for assignment 1, this is why we picked that individual user accounts option. When we pick that option, when we set up a new solution, we get a whole bunch of stuff related to security. We get a controller for account. We get an account view model and an identity model. We get a whole bunch of views. So we get this account subfolder with all of these views around logging in, logging out, resetting password. All of this stuff gets included in our project when we pick this. The other thing that it includes, which we really didn't look at, is a whole bunch of libraries. So anything here that says ASP.NET Identity, so here's the core one, here's the library that talks to that OWIN middleware, here's the one that talks to Identity Framework so we can connect to our database. And then there's a whole bunch of OWIN libraries, and these should be self-explanatory. What do these do? Yeah, when we enable authentication, it includes libraries for doing social login automatically. And most of the code is already written for us to use these. And we're going to try to implement at least one of these today. Hopefully, we might even be able to do a couple of different sign-ins, maybe Google and Facebook. We'll see what we have time to do. So all of the things we need for this are already here. So these ASP.NET Identity packages are going to do one other really useful thing for us. They're actually going to build in our database all of the tables we need to manage user accounts, roles, and permissions. We don't have to create tables for this. They're going to be generated for us. So here's our database right now. Here are the 5 tables that were in that script we ran on Blackboard a couple weeks ago. So everybody, your database probably looks like mine. So what's going to get added are these tables. So they all start with the prefix ASP.NET. We're not really going to need all of them. The ones we're primarily concerned with are these 3. And there are more fields. The users table will be used for storing user accounts. We will set up a couple of different roles. We'll set up an administrator role and a customer role. And then we'll create 2 accounts for ourselves. One account that's an administrator account that can modify the product catalog and the categories, and one that's just a customer. They can log in and they can order, but they can't change the products or the categories. We won't really worry about these tables. So I'm going to show you what this looks like. So I'm going to go to register. Now, just so I know, I'm going to ask some of you, but not all of you, to register. So pay careful attention to this part. Who in here is using my database on Azure? If you go to web.config, you're using my database, not your own. Okay. If you are using my database and not your own, don't create these accounts. I'll create the accounts and I'll just give you a login. Okay. If you are using your own database, then you can go click on your register link. And let's create 2 accounts, and I'll give you the username and password so that way you don't have to remember it. We'll just create the same accounts for everybody. Okay. So let's create first an account called admin@gc.ca, and I'll write the password on the board. And this library requires strong password. It has to be a minimum of 6 characters. There has to be an uppercase character, a lowercase, a number, and a special character. So here's the password. We'll use the same password for both our admin account and our customer account. I'd encourage everyone to use these same 2 accounts. That way no one is going to come in next week and say, oh crap, I can't log into my everything store because I forgot the credentials. So I'm going to use that password. I'm going to create an account. Again, if you're using my database, you don't need to create the account. Well, you can just use this login. Yes, so you'll notice a couple things. The register and login links are automatically replaced with hello, my username, and log off. Here's the magic part. When I click refresh, and go to tables, the identity and OWIN packages automatically built our 5 new tables. So we didn't have to set these up ahead of time. If they're not here, the first time we try and register an account, ASP.NET Identity builds the table. So what does this look like? Let's go look at my user. So if we query the table, now I could write a query, but I just can right-click the table and choose select. So here's what we get. So it gives me a long string. That's my user ID. It both hashes and salts the password. So this security stamp is doing salting. What does that mean? And why is this more secure than just hashing? Why is salting and hashing better than simple hashing? Somebody knows, I'm sure. What happens if I don't use salting? Here's a hint. If I don't use salting, what happens if I create another account with this exact same password? What will it look like in the database? If I create a second account and I use the same password as my admin account. The value gets hashed. Quick, go ask Google. What does salting a password do? Let me know when you find an answer. Found an answer? You can guess, it's okay. It's not sure? Okay. Sorry? Right, so salting, or what's this security stamp, it generates a random string. To generate this hash, we take both the value the user entered and this random salt value that here's called a security stamp, and we use those two values together to hash and come up with the final password. If we only hash the password and 10 people put in this exact same password value, the hash value here is going to be the same for every one of those users. So salting takes a random value and applies it to a hashing algorithm with a plain text value. This will ensure that every password is unique. If we have 1,000 users that all enter this same password, in the database, each one will be in a unique value because it will be combined with some kind of random text, some kind of random string. So this is all done automatically by ASP.NET Identity. We don't have to do anything in order for this to work. So we didn't have a field for phone number, but it also includes the ability to enable two-factor authentication. So if we want somebody, for example, to have to respond to a text message code every time they log in, we can do it. If we want to lock out accounts after a certain number of invalid login attempts, there's already the ability to do this. So a lot of the security infrastructure we're going to need is built into ASP.NET Identity, which is useful. So now I can log in and log out. If I click log off, notice I get register and login coming back. If I go to my login screen and log in, it recognizes me again. So as I said, if you're working with your own database, create the account. I'll write the username on the board as well. So we can register and log in. We didn't have to change any of our code. It's all just due to the way we set our project up. But everything is still all public. If I go in a private, if I open a private window where I'm not logged in, I can still go to products. I can still go to categories, no problem. And I can still add, edit, and delete as I like. Mo? Sorry, what? If it doesn't show up, you just have to click refresh. So choose your database and hit the refresh button here. Okay, the usual cause of it is this. I want to come back to something we talked about several weeks ago. Just close all my files up. There's one really important thing we have to do or none of this stuff works. In web.config, all of the ASP.NET Identity packages that are doing all this work, they all are looking for a database connection string called default connection that I've highlighted in blue. If you call your database connection string anything else, the packages don't work automatically. You'd have to override their settings to tell it what connection string name you're using instead. So this is why I emphasize when we set this up, we connected to the database 2 weeks ago, I emphasize the importance. Your assignment 1 would have worked without this. You call your connection string anything you want, but ASP.NET Identity, it needs that name or it doesn't work. So that's the likely cause, Mo. So that's good. I'm sorry you got the error, but I'm glad you got the error because that's useful for us to learn from. Okay. So now let's start. What we want to do, this is going to be super easy. We want to make it so that, actually, let's deal with products first. We want to make it so that you can only access anything in the products if you're logged in to the site. As an anonymous user, we shouldn't be able to access any of the views. And in fact, later on, we want to even hide the link. You don't see the product link until you're logged into the site. I could show you how to do it, but I'm going to give you a hint and see if anybody can find the solution. In order to make everything in products, with the exception of the link, to make all of these views private, we actually need to add one line of code to the project. One line will block any anonymous access to create, index, edit, details, and delete. So see if you can find online, what is that one line of code we need to add? And where do we add it? Or you can go get coffee shortly. Take a break in a second. We'll get this working, be one line of code, and then we'll take a break. And I'll give you a hint. This line of code is going to belong in the products controller. Right? It controls the logic for everything to do with products, all the methods and views. The logic is there. So one line of code in there will make this whole thing private. So I'll go to my products controller. So you found it, Nihal. So where should we put it? Okay, can you be a little more specific? Tell me what line number I should insert it. You've got the right code. Okay, so right here, so here's our class declaration, right? There's our products controller. So if we put on, in square brackets, an annotation that says authorize, and we build, that should be all we need to do. And now only if we're logged in can we access any of the views, call any of the methods in this controller. Let's try it. So put it right above the declaration of the controller. Now keep in mind, we're not dealing with roles and permissions yet. We're just dealing with identity. So right now, any user in any role, as long as they have a valid login. So let's try this. So I've got two windows here, two windows. In this one, I'm logged in. So now if I go to products again, my page should reload because I'm logged in with my admin@gc.ca email. And I'll try it over here in my private window where I'm not logged in. Because, you know, it doesn't have my username up in the top right. So I'll try it in both windows. So this is my anonymous window. Here's my authenticated window. So when I'm authenticated, no problem. I can go to my index view. I can create new. I can edit. Can do whatever I want here. As an anonymous user, when I click products, notice where it takes me. It now automatically takes me to the login screen, but it does give me a URL of where the page I requested. So if I log in, now it will log me, validate my credential, and it'll take me back. So if I go here, it should redirect me back to the page I requested, which it does. So that's super easy. At the controller level, all of the views are locked unless I'm logged in. So even if I try and go this way, I go to edit, right? Bounces me here, but it also shows me what URL as well as the parameters. This is really helpful in trying to identify hacking attempts. If we want, we could set it up to email any unauthenticated requests to us, and we can include the URL. So we can see what pages were people trying to access that they didn't have the proper login to go and do. And this is also typically where we'd see SQL injection attempts. I used to wake up every morning and see these. I used to see URLs that people were locked out of with things like this. So I knew that those hacking attempts were happening. So this is at the controller level. So we can, and we'll play around more. So this will block all the methods in the controller. We make a new method in view, it's automatically private. But we also can override it, or we can do this one method at a time. Let's say we have 10 methods. We want 2 of them to be private and the rest are public. In that case, instead of making the authorized annotation up here, we could just put it above any individual method. Or if we want most of our methods private, but we want a couple of them public, we can override it in those specific methods. We'll look at how we do that after the break, but pretty simple to do. So we have full control over this, either at a controller level or one method at a time, whichever we prefer. So we kind of looked at this first version of it. We'll still have to deal with this link. We want to hide that link entirely. So we'll have to deal with that. And then we'll have to look at roles and permissions. So not only do we want to be logged in, but we have to be an administrator in order to get there. So let's take our 20-minute break here. Okay, I have to step out. Got a few things I need to take care of. And if I can make it back before 12:30 to answer a few questions, I will. Okay, so let's take 20 minutes here.